Hello students, let's try to understand the concept of coordination compound student. Okay, in the coordination compound the first things are there student double salt. Coordination compound are also known as coordination salt student. So here you see firstly you try to understand double salt student, because coordination compound and double salt both are the different things. The double salt exists only in solid state and dissociate into ions in water. They lose their identity in solution. Okay, so when you are dissolving any of the double salt like that carneliite student, they will dissolve in the ions. It will give K plus ion, Cl minus ion, Mg2 plus ion, Cl minus ion. So they will lose identity student. Okay, and they generally found in the solid state. Third one, the properties of double salt are essentially the same as those of constituents compound. Okay, so constituent elements are having the similar properties. Next, in double salt, metal ion exhibit their normal valency. Double salt contain ionic bond, so always you will find that double salt is having ionic bond. If you see student, if you can see the example, let's try to see the example of double salt student. What are the example here you will find student? Here is KCl is there, MgCl2, no, KCl MgCl2 dot 6H2O, K2SO4 Al2SO4 whole thrice dot 24H2O, FeSO4 dot NH4 whole twice SO4 dot 6H2O. So these are the example of double salt. Next one is coordination compound. We have to understand the coordination compound. So are the coordination salt student? They exist in the solid state as well as in the solution. They do not completely lose their identity in the solution. They are not going to lose the identity even just like the double salt student. The properties of coordinate compound are different from the constituents compound. So their properties is going to be what student? Going to be the different. Now let us see the next point. What the point they are saying student? In coordination compound, metal ions is surrounded by number of anions or neutral molecule. The metal ion exhibit more than its normal valency. Coordinate compounds may have ionic as well as coordinate bond. So both side type of bonds may be possible. So here you see student K4FeCN6, then K3FeCN6, then Na3 Als2O3 twice. The transition metal ion form the coordinate compound because of the few region they are having student. Okay, why they are forming the coordinate bond if you talk about? So there are first one, they have a small size. Transition metal ion have a small size. They have high nuclear charge. Third, they have vacant d orbital. Fourth, they can accept a lone pair of electron. So these are the reason. Now we are going to understand Werner theory student. Werner theory. According to Werner theory, father of coordination chemistry, transition metal possess two types of valency: primary valency, ionizable valency; secondary valency, non-ionizable valency. Now student, you see the primary valency. What is the primary valency? It is referred to as oxidation state. It is satisfied by only anions. It is represented by dotted lines while writing the structures of the complex. Okay, so they are the three are there. It is referred to as oxidation state. It is satisfied by only anions. It is represented by dotted lines while writing the structures of the complex. Okay, this is there. Now here students see the secondary valency. What is the secondary valency? Secondary valency, non-ionizable valency. It is satisfied by anion or neutral molecule or rarely with cation. The groups satisfying secondary valencies are called ligand. The number of secondary valencies is equal to the coordination number. It is represented by thick line while writing the structure of the complex compound. In some complexes, the same group satisfied both primary and secondary valencies. Okay, next one, see student. The ligands are directed in a space around the central metal atom in different way. This leads to definite geometry to the molecule. So yellow color is there. Okay, so 4 ions, number of ions in solution. So CONH3 6 rhyme 3Cl, it will give yellow color. Purple color, it will give 3 ions. Green color, it is going to give what, student? 2 ion. So if it is the, okay, 2 ion. If it is the violet color, student, in case of 2 ion. Now let's say the Werner theory in detail. If you talk about COCl3.6NH3 complex, so coordination number is 6. So 6 bond it is going to have, student. See, 6 solid line are there, and here is Cl3 are there. This is the dotted line. So this dotted line are represented by the what? Non ionic bond, ionizable valency. 3Cl satisfied primary valency, 6NH3 species satisfied secondary valency. Ion in solution 4. AgCl molecule precipitated on ending AgNO3, 3AgCl. So ionizable valency is 3. So this is how we have to understand, student. Now we have to understand failure of the Werner theory. Why the Werner theory got failed? Defects in Werner theory. This theory does not relate the electronic configuration of metal with the formation of the complex. It is known now that the metal tries to acquire the nearest inert gas configuration during the formation of complex. This theory does not explain the reason for the color of the complex. This theory does not explain the magnetic behavior of the complex. So these are there, student, 4 points that we have to understand, that why the Werner theory failed, student. The reason is this theory does not relate the electronic configuration of metal with the formation of the complex. It is known now that the metal tries to acquire the nearest inert gas configuration during the formation of complex. This theory does not explain the reason for the color of the complex. This theory does not explain the magnetic behavior of the complex. So this is what the answer is, student. Thank you very much for watching.